In this video, we are going to continue talking about our measures of relative position. So in the last video, we looked at percentiles, and in this video, we are going to be looking at what we call quartiles. So quartiles are very much related to percentiles. They're just a specific case, and these are the markers that divide the data into 4 equal parts. All right, in just a second, I'll give you a little time to write that down. But there are going to be 3 quartiles that we are going to find. And again, the process of finding these is going to be very similar to how we found the percentiles from the last video. All right, so our 3 quartiles are as follows. So we have Q1. Q1 is the 25th percentile. All right, so when we're looking for Q1, we're just going to be looking for that 25th percentile. So we're going to use the same 3 steps. We're going to use the same formula for the location, so on and so forth. Q2 is the 50th percentile. We've actually already found a Q2 in the percentiles video. One of the examples we did was the 50th percentile. That was Q2. It also has another name, which is the median. Right? It's going to be the value or the average of the values in the middle of our data set. And then we're going to have Q3, which is the 75th percentile. All right, so really, the reason that we're flashing that up there is because just telling us how to find these, right? What P needs to be in our location formula. And finding them, it's going to be done just like we do our percentiles. All right, so let's go ahead and start talking about some of the reasons why we are looking at this specifically. Why do we have this as a, why do we have this special case? All right, ultimately, one thing that we are going to use this for is to look at the existence of outliers. All right, and just to look at our data in general. All right, to get to that point, we're going to have to look at a couple of things. The first one being the IQR, all right, or interquartile range. So the IQR is the range for or of the middle 50% of the data. All right, so that middle 50% of the data, what's the range? That's our IQR. And our IQR is going to be calculated by taking Q3, our 3rd quartile, and subtracting Q1, our 1st quartile. All right, so that is the that middle 50%. All right, and we're going to do examples of all of this all together. It just kind of all goes together, so we're going to wait till the end and until we're done looking at all of this stuff, right? But that is our IQR. The last thing that we're going to look at before actually doing an example, or one of the last things, is a box plot. All right. These are also sometimes, that's not how you spell plot. These are also sometimes referred to as box and whisker plots. Right, but what this is, it is a graphical summary of the central tendency. All right, so our measures of central location. It's going to give us an idea of that central tendency. It's also going to give us an idea of the dispersion. Right, it's one of our other types of measures. And the potential existence. Of outliers. Right, so it can help us kind of identify those things. Right, so a box plot is made up of 5 pieces of information. Right, those pieces of information that we need are the minimum, the maximum, and then our quartiles. Right, and so that's what a box plot is going to be based off of. So I'm going to also just write that down. So based on max, min, Q1, Q2, and Q3. So to find Q1 and Q2, we already have to put our data in order, so that's going to make it easy for us to find that min and max. And finding Q1, Q2, and Q3 not going to be terribly hard either. All right, another good thing about these box plots is that if we draw these out when we're doing a problem, most of the time you're going to be asked to at least kind of evaluate that. It can help us avoid making some common mistakes. So let's go ahead and wipe this and then actually put up an example of what a box plot might look like. So ideally, these would be drawn to scale. When you're actually drawing them by hand, that's not really, at least for me, it's not reasonable to expect that. But this is what it would look like. All right, so here obviously we don't really have any of these numbers because we haven't done an example yet. But this is the way it would look. Right, we would have here at the lefternmost. So here this box. This kind of shows us that IQR. That interquartile range, right? The difference between Q1 and Q3, right? That middle 50% of the data, right? So that's the box from the box plot. These little bits over here that come off of the box that go out to the max and the min, those are the whiskers, right? So that's why it's sometimes referred to as a box and whisker plot. Right, but we have our minimum here at that leftmost whisker. Right, then we will put down Q1 at the first line there on our box. Then the one in the middle is our Q2, our median. Q3 is the far right edge of the box. And then at the far right end of the whisker, that is our maximum. All right, so just quickly running through those things that we talked about. So in the definition of a box plot, right, it's a graphical representation of central tendency, right, because we have the median here, right, so that's our central tendency. Then our dispersion, we don't have the, let's see, I don't think I can do that, can I? Well, we'll just leave it that way because I think it'll erase the, yep, it will. Okay, so we don't have the variance or the standard deviation, but we do have the IQR, right, for the, the range of the middle 50% of the data, right? And then we also have the range itself. So we kind of have two ranges, which are basic measures of dispersion, but they are still measures of dispersion, right? So we have those there. Then also with these whiskers, this is where our detecting potential outliers comes in, right? Because if our whiskers are really far away, right, the ends of our whiskers, if those are really far away to the box, right, the especially the middle 50% of the data, right, that's going to indicate that, you know, maybe we have an outlier, right? If let's see, so let's say that we had, again, these are kind of supposed to be drawn to scale. Right, that one wasn't necessarily, but if we were to look at something more like this, all right, I'll go ahead and label that as well. All right, so we see that relative to our box, right, this maximum value out here is really far away, right? If this is to scale, right? If we have some value that's way out, all right, if the whiskers are really long, really far away from the box, right, that's going to indicate to us, hey, you know, we might have an outlier here. All right, speaking of outliers, all right, we might not want to just rely on a box plot to determine whether or not, right? That might tip us off that we have an outlier, but we probably want to confirm it mathematically, all right? So a data point, or so an observation, may be considered an outlier if it does not fall into the following interval. All right, and so here is the interval. All right, so we've got a lower boundary, all right, that's equal to Q1 minus 1.5 times the IQR. I can already tell I did not give myself enough space to do this. I was writing too big. All right, let's try that again. All right, so Q1 minus 1.5 times IQR. And then our upper boundary is Q3 plus 1.5 times IQR. All right, so that got a little cramped there at the end, but hopefully that's still legible. All right, but so we have, all right, so essentially what that's saying, all right, is if any value is less than, or is more than 1.5 times that range of the middle 50% of the data. If any value is more than, that's a terrible way of saying that. If any value is below, right, one and a half times the range of the middle 50% of the data, less than Q1, it can be an outlier, right? So essentially that middle 50% of the range of the middle 50% of the data, that's our IQR. So if, you know, you multiply that by 1.5, if the amount you're lower than Q1, but this is just a confusing way to say that. Maybe we should just avoid that and just say it normally, right? So Q1, that's the minimum for the 50%, that middle 50% of the data. If some other value is less than that value by 1.5 times the IQR, it can be considered an outlier. Same thing with this upper boundary, all right, for our Q3. If any of our values are 1.5 times the range of the middle 50% of the data, larger than that, all right, that's a pretty big difference. All right, we can consider that an outlier as well. All right, so now that we've got all of that down, all right, we can put it into practice with an actual example. All right, so I'm going to go ahead and put my data down. I'm going to see if I can fit this all on the top. So just with our percentiles, the first step for our quartiles is to put our data in ascending order. Once again, I'm already putting this in ascending order because I doubt anybody wants to watch me write down the same set of numbers twice. I know I certainly don't want to do that. But in most kind of evaluations that y'all have, these will not be in order. You will have to order them yourself. All right. What we'll start doing is just kind of going down the line and finding those important pieces of information. All right. So really, we'll start with our quartiles. All right. So we want to find Q1. All right, so to do that, all right, one, we need to put our data in order. That's already done. Second step is that we need to find the location. All right, so the location of the first quartile. All right, so remember our location formula is L equals N times P over 100. All right, in this case, we need to find our sample size. We count those up. We should find 10, unless I did something wrong. Let me just double check. Nope, we do have 10. All right, P, well, what's P? It's 25, right? So Q1 is the 25th percentile. So when we're looking for that, we're going to find P is going to be 25. All right, so 10 times 25 over 100, that's going to give us 2.5. All right, we're going to round that up, right, because we don't have a whole number. If we don't have a whole number, we're going to use the 3.A, which tells us to round the number up, right? And so we get a 3. That's telling us that the Q1 is the third number in our ordered data set. So 1, 2, 3, right? And we can see that 96 is our Q1, or another way of saying that is Q1 equals 96, right? And that's all we have to do to find Q1. All right, so then we're looking for Q2. Again, we're going to start by ordering our data if we haven't already, which if you're on Q2, you probably have already ordered that data. But then we're going to find our location. So L equals 10 times P over 100. What's P? Well, Q2 is the 50th percentile. So it's going to be 50 over 100. All right, so 10 times 50 over 100, that's going to give us 5. All right, so this is a whole number, so we're going to have to find the number in the 5th location. And we're going to average it with the value in the 6th location. So remember that when our location calculation is a whole number, that we're going to take the value in our ordered data set at that location, in this case 5th, and then the next one, and average them together. So that L, the average of L and L plus 1th values. All right, so when we do that, we're going to take, so Q2 equals 117 plus 126 over 2, and that is going to give us a Q2 of 121.5. All right, so I'm going to mark that up here. So this yellow line is Q. Actually, I guess we could just label all of these. That's not going to hurt anything. All right. So let's get rid of some of this other stuff because we still have one more quartile to find. And I'll write all of this back down, the actual end results here in a moment. All right, actually, I'm just going to go ahead and erase all of this. All right, so now we are looking for Q3. So once again, our data is already in order. We need to find the location. All right, what is P going to be for this one? Well, Q3 is the 75th percentile, so P is 75, so 10 times 75 over 100, we get 7.5. We are going to round up because we got a we did not get an integer, we did not get a whole number. So we're going to count out and we're going to say, well, the eighth number is our third quartile, so 1, 2, 3, 4, 5, 6, 7, 8. And we're see that 138 is our Q3. All right. And now that we have this, there's another thing that we can kind of see is that we said that the quartiles or markers that divided the data into 4 equal parts. And look at that, we have 4 equal parts divided by this data with 2 values in each kind of section. All right, so 2 values before Q1, 2 between Q1 and Q2, so on and so forth. All right, the next thing that we probably want to do is we want to find that interquartile range. All right, we know that our interquartile range is our Q3, so 138, minus our Q1, which is 96. And so that's going to give us an IQR of 42. All right, so we could, I guess, well, let's go ahead and just do this part. All right, so that is our Q3. So we found all of our quartiles. We found our IQR. Let's look at outliers before we look at that box plot. All right, so we want to detect our outliers. We want to see, are there any outliers? All right, and usually if I'm asking you a question like this on the test or on a homework, I'm going to say, are there any outliers? If so, which ones? And then explain your answer. All right, the explanation is that interval you calculate. Right, that's really what I'm wanting. I don't want you guys to just say, hey, just pick the biggest and smallest, or just the biggest or just the smallest, and just kind of guess that way. If you don't give me that interval, you're not going to get any points. All right, so let's calculate our interval. All right, so our lower boundary is Q1. So 96 minus 1.5 times the IQR, which was 42. And our lower bound was Q3, 138, plus 1.5 times the IQR, which of course, as we just said, was 42. All right, so once we punch those into our calculator, we're going to get a lower boundary of 33 and an upper boundary of 201. All right, so if any values in our data set do not fall between 33 and 201, they can be considered outliers. All right, so looking at this, all right, we've got 33 to 201. Well, there are 2 values that don't fit into that interval, right? So 11 is less than 33, and 219 is greater than 33. All right, so are there any outliers? Yes. 11 and 219 are outliers. Because they do not, and I'm not going to write the rest of that out, but they do not fit in the range, mostly because I was running out of space. All right, so, but for the kind of explain, if you've got this, you don't need to try to make some overly complicated explanation. Just say it wasn't an interval, right? As long as you've got that interval, that is all the explanation you need. All right, so that is how we detect outliers. All right, so before we do, well, I guess before we end, we're just going to essentially just do the box plot. All right, and again, I'm not going to draw this to scale just because I don't think I could if I wanted to. Ooh. Right, I'm doing good to just barely get almost straight lines, which they're not even that straight. Right, but so if we go back, we look at our information. We get this as our box plot. All right, so this is what our box plot should look like for this example. All right, we've got our minimum right here, that's 11. We knew that from when we put the data in order. Similar vein, 219, we knew that was the max from just writing it down. And then our quartiles, right, we got those, we want to put them in the right spot. Right, so really there's not a whole lot going on with these box plots, at least as far as kind of putting them together. What they can be very useful for, though, is to help us avoid mistakes. All right, I'm just gonna, well, actually I don't need that. All right, so this is the correct version. All right, I'm gonna show you a couple of incorrect versions that would help us identify some common problems, though. All right, so if you write these down, I'm just gonna be switching the numbers around. If you write these down, though, please notate that they are not correct. All right, so actually I'm just gonna write incorrect up here. All right, so let's say that we have a something that looks like this. All right, so if for this example, if you work through it and your box plot looked like this, right, this would be incorrect, right? And the problem here are your quote-unquote quartiles. All right, so 3, 5, and 8. All right, so these are locations, right, not quartiles. All right, one thing that can help us see that is look at the numbers that we already have, right? So our minimum is 11, our maximum is 219. So is it possible for us to get a 3, a 5, or an 8 in our data set? All right, and the answer to that is no, right? These numbers, right, that are on our box, right, the ones that are supposed to be our quartiles, right, they need to actually be between our minimum and maximum, right? Right? If they aren't, we've made a mistake, right? If most of the time I'm not going to give you numbers that are in the single digits for these. Most of the time you're not going to, your location calculations, those are not going to be within the data set, right? So that's probably the most common reason why your box plot might look like this or something like this, right? But definitely it's an easy way to just double check things. And you don't want to lose points just because you did half of what you were supposed to, but didn't actually finish it up. All right. Another thing that probably, I don't know, let's say that maybe your box plot looks something like this. Actually, most of the time you don't do that. Well, it doesn't really matter. All right. So let's say it looks something like this. All right. So again, kind of these box plots, right? The numbers are going to run left to right, smallest to largest. Right, and so they should be in order. So if you've got a box plot that looks like this, where you've got 103, then 219, so far so good. Then you get to 95. Well, that doesn't really make any sense. 95 is less than both 103 and 219. Right. what probably happened if you run into this scenario is that you did not sort your data. All right. If you've got a bunch of stuff that's real jumbled up and kind of all over the place, more than likely it's because you didn't sort that data. So unfortunately, you're going to have to go back. So this is kind of the worst one, because you have to actually go back and rework the entire problem from the beginning, because you got to put your data in order. All right, and then, well, I guess you would know the location of stuff. I guess you wouldn't be that far off. But you would have to go back and put that data in order. So it probably wouldn't be too grueling to fix it. But again, it's better to have to spend a little extra time working on something to correct it than getting it wrong on the test or the homework. All right, let's see. I think that is it. If I think of anything else, I'll make a supplemental video. But I think that's it for kind of why, kind of the tips on these box and whisker plots. All right, but with that is the end of kind of our section on outliers on quartiles. The next, so we're going to go ahead and end that there. The next video is going to be a very short one. We're not going to spend a whole lot of time on the thing we're going to talk about, but I don't want to make this one any more longer because it's already about 30-ish minutes. So we will end there, and I will see you guys in the next video.